In this video, I'll explain the proof of Cauchy's mean value theorem. This theorem is also called as generalized mean value theorem or second mean value theorem. Let us see the statement of Cauchy's mean value theorem. Here we are using two functions. Let f and g be two real valued functions defined on closed interval a comma b such that both f and g are continuous on closed interval a comma b. Both f and g are differentiable on open interval a comma b, and the third condition is g dash of x is not equal to 0 for every x belongs to open interval a comma b. If all these three conditions are satisfied, then there exists a point c in open interval a comma b such that f dash of c by g dash of c equal to f of b minus f of a divided by g of b minus g of a. Lagrange's mean value theorem is particular case of a generalized mean value theorem that is obtained by taking g of x equal to x. Then we will get f dash of c equal to f of b minus f of a divided by b minus a. Geometrically, if any two functions satisfy these three conditions, then you can always find a point C in between a and b such that the ratio of slopes of their tangents at the point C is always equal to the ratio of slopes of secants to those two curves drawn at the end points. Let us prove this theorem. So to prove this theorem, I will define a function phi of x as f of x plus k into g of x, where k is any constant, and this function phi of x is defined on closed interval a comma b. Now, we will apply Rolle's theorem for the function phi. So first we have to verify whether conditions of Rolle's theorem will they satisfy for the function phi. So first condition of Rolle's theorem is phi should be continuous on closed interval a comma b. So clearly phi is continuous because it is the sum of two continuous functions. F is continuous, g is continuous, already given in the statement. Therefore, sum of two continuous functions is always continuous. Therefore, phi is continuous on closed interval a comma b. Similarly, phi is differentiable on open interval a comma b because phi being the sum of two differentiable functions, it is also differentiable on open interval a comma b. Third condition of Rolle's theorem is phi of a must be equal to phi of b. So let us write phi of a equal to phi of b. This is possible only if, that is if and only if, f of a plus k into g of a equal to f of b plus k into g of b. Put x equal to a and put x equal to b. We have to find the value of k for which this condition satisfies. So let us simplify this. K into g of a minus g of b is equal to f of b minus f of a, which implies k is equal to f of b minus f of a divided by g of a minus g of b. So for this particular choice of k, phi of a equal to phi of b satisfies. Therefore, all the three conditions of Rolle's theorem are satisfied for the function phi. Hence, by the statement of Rolle's theorem, there exists a point C in open interval a comma b such that phi dash of c equal to 0. So what is phi dash of c? Phi dash of x is f dash of x plus k into g dash of x. So I want phi dash of c. So phi dash of c equal to f dash of c plus k into g dash of c. So which is equal to 0. Therefore, I want the ratio now f dash of c by g dash of c. So hence, f dash of c divided by g dash of c, which is equal to minus k. So f dash of c equal to minus k into g dash of c. So f dash of c divided by g dash of c is minus k, which is equal to, substitute the value of k, minus of f of b minus f of a divided by g of a minus g of b. I can rewrite this as, by taking minus common here, f of b minus f of a divided by g of b minus g of a. So f dash of c by g dash of c equal to f of b minus f of a divided by g of b minus g of a. Hence we proved the Cauchy's mean value theorem. Now see one example. Verify Cauchy's mean value theorem for these two functions on the closed interval 2, 4. Let us verify the conditions. Both f, g are continuous on closed interval 2, 4 because both are polynomials. Then second condition, f, g are differentiable on open interval 2, 4. So because derivatives exist for both functions, f dash of x equal to 1 and g dash of x is equal to 2x. Now third condition is g dash of x is not equal to 0 for all x belongs to open interval 2, 4. G dash of x is 2x. 2x cannot be equal to 0 for any value in the open interval 2, 4 because 2x equal to 0 only if x equal to 0, but x equal to 0 is not there in this open interval. All the three conditions of Cauchy's mean values theorem are satisfied for these two functions f and g. Therefore, by Cauchy's mean value theorem, there exists a point c belongs to open interval 2, 4 such that f dash of c by g dash of c, which is equal to f of b means 4 minus f of 2, a means 2, divided by g of 4 minus g of 2. So, f dash of c is 1 itself, 1 divided by g dash of c is 2c, which is equal to f of 4 means, put x equal to 4 here, 4 minus f of 2 is 2 divided by g of 4 is 4 square 16 minus g of 2 is 2 square 4. So 1 by 2c equal to 2 divided by 12, which is equal to 1 by 6. Now let us simplify this. 1 by c equal to 2 by 6. It is 1 by 3. So which implies c equal to 3. This belongs to the open interval 2, 4. Open interval 2, 4. Therefore, we have found a point c in the open interval 2, 4 using the Cauchy's mean value theorem. The generalized mean value theorem can be stated using the concept of determinants as well. So suppose if you have three functions f, g, h which are continuous on closed interval a, b and differentiable on open interval a, b, then you have to define d of x, determinant of x, as determinant of f of x, g of x, h of x, f of a, g of a, h of a, f of b, g of b, h of b. Then you can always find a point c belongs to open interval a, b such that d dash of c equal to 0. So d dash of x means differentiating the first row with respect to x, f dash of x, g dash of x, h dash of x, remaining two rows as it is. This is d dash of x. D dash of c means replace x by c. Then equate that to 0 and you can take the help of determinants to evaluate the value c. You can note that if we put h of x equal to 1, we get Cauchy's mean value theorem. If we put h of x equal to 1 and g of x equal to x, we get Lagrange's mean value theorem. Because Cauchy's mean value theorem we have stated for two functions. So when you take h of x equal to 1, you get it as Cauchy's mean value theorem. When you put h of x equal to 1 and g of x equal to x, then we will get Lagrange's mean value theorem. And if you have three functions, then you can go with the concept of determinants to evaluate the value of c. Hope you understood this concept. Thank you for watching.